Welcome back for the chapter 6.5 notes. In this lesson, we're continuing to learn about radical expressions and what mathematical operations we can do with them. And in this lesson, we're going to learn how to multiply and divide them. So we're really just applying some of our rational exponent rules. We're also multiplying as long as our radicals have the same root, we can multiply what's under the radicand. So for instance, these are both square roots, so it'll still just be a square root of 6 times 2, which is 12. And then we should simplify that into factors that can be rationalized. As far as the square root of 4 is 2. So this could be 2 times the square root of 3. Now on letter B, we're again multiplying. We're going to multiply the integers on the outside. So 3 times 2. I'm going to show you. And then we're going to multiply the square root of 5 and 7 because they're both square roots. So this becomes 6 times the square root of 35. And 35 does not have any factors that can simplify. Letter C, we have 2 times 6. So the two integers will get multiplied, the 2. And then because this is a cubed root and this is a cubed root, they're both cubed roots. So we can multiply just what's under the radicand together. So this is 12 times the cubed root of 8. And 8 has a perfect cubed root of 2. And this ends up being 24. So again, as long as they're the same radical, we can go ahead and multiply them. So this is going to be using our distributive property over addition. So 5 times the square root of 6 plus 4 times the square root of 4. The square root of 6 cannot be simplified, but the square root of 4 can be. So this is 4 times the square root of 6 plus 8. 5 times the square root of 6 plus 8. And now we're going to be distributing again, but this is 2 terms times 2 terms. Here's my 2 terms there, and then here are 2 terms here. So 2 times 2 makes 4 products, remember? So we're going to use our FOIL. So FOIL is the first. So this is going to be 3 times the square root of 25. And then the one over here is going to be plus 2 times the square root of 10. And then the insides are going to be a negative 3 times the square root of 10. And then the last will be a negative 2 times the square root of 4. Now, this first term and the last term both can simplify the radicals. So this will be 3 times 5. And this will be a negative 2 times 2. And then notice that we have like radicals or like terms here because these are both 2 times the square root of 10 and minus 3 times the square root of 10. And it's just kind of like an X here or a star. It doesn't matter what the square root of 10 is because they're the same thing. We can add the number of those that we have. So we have plus 2 and minus 3. So 2 plus and minus 3 is a negative 1. So we really have minus 1 of the square root of 10. So we have 15 minus the square root of 10 minus 4. And we can combine our constants. So I'm going to rewrite that. 15 minus 4 minus the square root of 10. So this becomes 11 minus the square root of 10. Square root of 10 is irrational, so it cannot be simplified any further. Now, f is the square root of x plus 4 squared, which we really should expand and write it as this so that we remember that we have to use our FOIL. So that's going to be the square root of 16. And then, oops, I wrote that incorrect. This is x and this is 4. So we have the square root of x squared plus 4 times the square root of x plus on the inside is 4 times the square root of x plus 16 on the last. This simplifies into x, and then we have two like terms here. So we have 8 square root of x plus 16. Okay. G is similar in that we should really write this twice. So that we don't forget to FOIL that. So we have the square root of x minus 3 squared minus 4 times the square root of x minus 3 minus 4 times the same x minus square root of x minus 3. And negative 4 times a negative 4 is a positive 16. So this is the square root of the square of itself. So that just becomes x minus 3. And then we have like terms here. So we have a negative 8 times a square root of x minus 3 plus 16. And we can combine our constants of a negative 3 and positive 16. So we have x minus 8 times the square root of x minus 3 plus 13. H and I are just a few extras here for practice. So let's look at those. Distributing, we have the square root of a squared and then minus 5 times the square root of a. And this time it's plus 5 the square root of a and then minus 25. So that simplifies to a. We've got like terms that, oh, they actually add to 0 because they're opposites of each other. So minus 25. Cool. So that's interesting. If we look and see why they canceled, it's because they're conjugates. Remember, conjugates are unique binomials where the first term is the same and the second terms are just opposite signs of each other. So let's look at I. It appears that those are conjugates as well. And so conjugates always multiply to be the square of the first and then minus the square of the second. So that simplifies to 9 minus x. Conjugates are used when we want to rationalize the denominator, and we're going to need to do that now that we're going to divide radical expressions. So similar to lesson 6.3, we cannot have a radical in the denominator as it is an irrational number. So we will have to multiply by another radical to rationalize the denominator. If the denominator has two terms and one or both contain radicals, then we will multiply by the conjugate so as to eliminate the radicals. You can see that we have two radicals in the bottom. So if we multiply by the square root of 5, that will get rid of that, but it won't get rid of the square root of 13. And likewise, if we multiply by the square root of 3, it will do the same. So we have to multiply by the conjugate of the two together. So what that does on the bottom is we get the square root of 25. The middle terms cancel out. And then we'll have the square root of 9 minus the square root of 9. And then on top, we have the square root of 25 minus the square root of 15. So the top simplifies to 5 minus the square root of 15. And the bottom simplifies to 5 minus 3. And so we have 5 minus the square root of 15. over 2. So when we rationalize our denominator, we should always end up with a rational number, usually an integer. Okay, letter B. So again, because we have two terms, we need to multiply by the conjugate of the denominator. So we get the square root of 49 plus the square root of 7 over the square root of 49 minus 1. Remember, we already know that the middle terms will cancel because they're conjugates. So this simplifies into 7 plus the square root of 7 over 7 minus 1. And there is our final answer. The letter C here, again, we're going to multiply by the conjugates. Lots of practice with conjugates. So we're going to distribute that 2. And that's our final answer there. And another set of multiplying by the conjugates. And notice on top, they're not conjugates of each other here, so that we're going to have like terms that we're going to have to combine in the numerator. Now the bottom is conjugates. So the numerator simplifies to 5 and then minus 2 times that square root of 15 plus 3 all over 5 minus 3. So if we combine our numerator, 5 and 3 is 8 minus 2 times the square root of 15 over 5 minus 3 is 2. And it looks like we can cancel a 2 out of both terms in the numerator. So that simplifies to 4 minus the square root of 15. That cancels to 4 and those cancel. And our last one, multiplying by conjugates again. And this gives us the square root of 121 plus 3 times the square root of 11 plus another 3 times the square root of 11 plus 9. So the numerator there will be like terms to combine. Then the denominator, we have the square root of 121 because they're conjugates, the middle terms cancel, minus 9. So on top, this simplifies to 11 plus 6 times the square root of 11 because they're like terms, plus 9 all over 11 minus 9. So combining in the numerator, we have 20 plus 6 times the square root of 11 all over 2. And again, it looks like we can cancel out a factor of 2. That leaves 10 and leaves 3. So we have 10 plus 3 times the square root of 11. And that is all for lesson 6.5. Catch me back for another video.